Greetings. Welcome to my video on circuit network in Factorio. This series will attempt to provide a systematic approach to studying circuit, accompanied by specific scenario examples. There are plenty of guides online that showcase very intricate setups, but if you've ever wondered how people come up with these designs in the first place, that's what I'm going to try to cover in this series. It is my attempt to explain how I approach circuit design in Factorio as someone with little background in programming. I personally prefer a more mathematical approach, where you have clear and precise terminology and a set of fundamental principles or intuitions that you would want to follow. And if you are also not so well versed in programming, maybe my explanation here will be more intuitive for you. So I hope you will enjoy this video, and let's begin. Signals is the most fundamental notion in circuit networks. A signal in Factorio refers to a list of items, or what I call virtual items, accompanied with integer values. So what I mean by virtual items here is items like check marks. These are not items you can hold in your hand, but they are allowed in a signal. You can have a signal of 3 gears, minus 2 copper cables, and 1 check mark, as seen in this picture of the game, stored inside a constant combinator. Now, for simplicity, I'm only going to refer to the things in the signals as items. Now we say that an item is inside the signal S if it appears in S. So here I would say the gear is in S, the copper cables are also in S, and the check mark is in S. Now we can phrase this more precisely using a mathematical notation. So I would write a signal as the sum of items times a number. This is an integer, and we would say x is inside S if the integer is non-zero. And in the case that the coefficient here is 0, we can just omit it as usual in the sense of a sum, and this is consistent with what happens in the game if you have 0 of something in a signal that just simply doesn't show up. Now in Factorio, these signals are stored in channels. What I call channels, in game you might see them referred to as circuit networks. And entities in Factorio, such as machines or inserters or belts, they can host these colored channels, where the color is either red or green. We would say that a signal S can be streamed or recorded or stored in a channel. When you have two channels of the same color hosting two signals, they can be combined together using a wire of that color. In this case, the combined signal is simply obtained by adding the two signals using the summation notation. In this picture, I have constant combinators recording 3 gear and minus 1 check mark. The other one has 2 gears and plus 1 check marks. And if I combine them using a red wire, I'm going to get 5 gears and 0 check marks, which would not show up. Now I need to mention that I say the entities host colored channels, meaning that even though there's no wire connected to this constant combinator, internally it still has two channels, one red and one green, recording the same information, which we will see later. Now entities, I have categorized them into 4 types. A source, which generates a signal, such as an inserter where you can read its hand, or a reactor where you can read the temperature, or a constant combinator which can simply record some information. A 2 combinator is one of the 3 special combinators of arithmetic, decider, or selector combinators. A target is something that can be controlled by a signal, such as an inserter with a set filter condition, or an assembler with an activation condition or enable-disable condition. Now the last type is a special type, which we don't really care about. They are power poles, which are used for extending wires or display the signals for troubleshooting. Now let's go into more details about these entities. A source is an entity that generates 2 identical signals inside both its red and green channels. We say that an entity which generates 2 identical signals to have uncolored outputs because the output has no specific color. Therefore, we can say that a source is something that generates an uncolored output. In the picture you see I have a source which is an inserter where I set it to read its hand content, and right now it's holding 4 gears, and in both red and green channels I have 4 gears being recorded. And the mode I use for displaying these nice lines for wires is called circuit visualizer. Now a target is an entity that receives a signal from its red or green channel, and this signal can be used to determine its behavior. Something that's important to remember is that the entities have 2 channels associated to it. It has a green and red channel, and when it uses the signal it receives to make a condition, the signal it uses is going to be the combined signal. So in this picture I have a constant combinator with 1 iron plate. If I connect 2 wires of red and green, that would send 1 plate in red and 1 plate in green. And when the inserter uses the signal to determine the enable and disable condition, it's going to see 2 iron plates as the combined signal. And we say it has uncolored inputs. So a target is something that checks a condition about uncolored inputs. And if the condition is true, then it will behave in some specific ways. A 2 combinator is either an arithmetic combinator, a decider combinator, or a selector combinator. We have only 3. These are special entities because they have 4 channels attached to them, input and output, each having 2 colors. Now each of these behave differently, and for today we're only going to look at the decider combinator. The decider combinator determines whether a condition is true, and you can program the condition on the left-hand side in game. If the condition is true, then it outputs a signal that you can also program on the right-hand side. For a decider combinator, we will see that the input has 2 colors, and we do have the options to distinguish which color or input should be used for these conditions. For the output, you can either program an arbitrary item with a value of your choice, or you can use an input as your output, and the output is exactly the same as the input. Here you can also choose the color of the input. But down here, if we look at the output signal, there is no color associated to them, and indeed, the decider combinator has uncolored outputs. So we have, if a condition about a colored input is true, then the decider combinator generates an uncolored output. Let's look at a scenario which I call recycler stacking problem. The question is, how do you make the output belt of a recycler fully stacked? And this is usually solved by having the recycler outputting into a chest, and you put a stack inserter between the chest and the belt, and since the stack inserter always outputs in 4 stacks, this will solve the problem. Therefore, we can convert the question to, if we have a chest and a stack inserter, I want to set the stack inserter's filter to the items in the chest whose count has at least 16, which is the number of items in a full stack. The most common approach that you will find on the internet will be the following. You read the content of the chest into a decider combinator, and you check for each item in the chest. If the count of the item is greater than or equal to 16, then you generate a signal with that item of value 1, and setting this output signal as the filter of the inserter will achieve the goal. But remember, in this video, our goal is to explain how you would come up with a circuit design that solves this problem. And I will try to give you a systematic way of designing this circuit. So let's look at the 3 steps that I want to achieve in this circuit. The first, reading a chest would correspond to a source. The signal of the content of the chest would be an output of this source. Recall that a source generates an output that's uncolored. We have to route this output somewhere using some wire. So let's just take a green wire and connect to this output, which we call channel green 1, G1. Next, I have a condition I want to check and make an output from the condition, which means I need a decider combinator. And remember, the decider needs a condition, colored input, and then uncolored output. For the input, we take the content of the chest, which is with the channel G1. For the condition, I would want to check for each item in this signal, so I put each for the condition, and I want to see if it's greater than or equal to 16. If it is, then I want to return each of these signals with a value of 1. Therefore, my output should be each with a value of 1. And lastly, I need to set the filters of the inserter to an output signal. The inserter here will be a target. And remember, a target needs a condition, an input, and a behavior. The condition is hidden here because the set filter behavior takes in a signal, and if the input is greater or equal to 1, it will be part of the filter. So that's the condition. The input will be the output of the decider. Because the output of the decider is uncolored, we can pick an arbitrary color, and we call this channel G2, and put that into the inserter. And setting the filter to it will complete this implementation for circuit. Now with this design, I can implement it in-game. So for the source, I have a chest. The output of the chest should be directed into the input of the decider, which I call G1. The condition of the decider is each greater or equal to 16. The output of the decider is each with a value of 1. Finally, the target is the stack inserter. Its input is the output of the decider, which we called G2, and the behavior of the inserter is set filter. With this format, it's very easy to implement the circuit, and it's much easier to trace through what happens than if someone just gave you a blueprint. Now, lastly, I wanted to mention another implementation of this circuit. I have a decider combinator with a condition that is always true, and it outputs everything it receives with a -15. So it takes in the content of the chest and converts it to a -15. Then you add the content of the chest to the -15. The final value will be greater than or equal to 1 if the chest has at least 16 items. But there is a problem to this design. Namely, if I drop one item into the chest, the inserter takes it out. Now the mistake here will be discussed in the next video. A quick explanation is that the moment I drop an item into the chest, it sends a +1 into the inserter, which sets the filter to that item. It also sends a 1 to the decider combinator, but the decider takes one frame to convert the 1 to a -15. And within that one frame, the inserter has already taken out the item. This is an important feature that will be used in a lot of advanced designs, and we will be looking at it in the future. Now that is the end of the video. Thank you very much for watching. I hope you liked the video. Now I know some of you would ask, why don't you just connect the inserter to the recycler? And what? Oh, I didn't expect that. I thought you can't do that. Oh, that was strange. It seems they have updated the recyclers so that you can read its content. So here is a simpler design where it uses only one constant combinator. You do this by creating a list of all the items that could potentially be the result of the recycling. You set them to -15 and you add them to the content of the recycler. And if the content of the recycler gets above 16, it will allow the inserter to take it out. Okay. Bye.